This is a practice paper for the Edexcel higher tier, paper 3 for June 2023. Question 1. We're given that A is 2 cubed times 3 squared times 5, and B is 2 squared times 3 cubed times 5, and we need to write down the highest common factor of A and B. So we're given two numbers already written as a product of their prime factors, and we need to find the highest common factor. So for the highest common factor, we're looking at the ones they've got in common. So A and B, they both have 2 2s, 2 3s, and a 5. A's also got an extra 2, and B's got an extra 3. The highest common factor are the ones in common multiplied together. So the highest common factor is 2 times 2 times 3 times 3 times 5, 2 times 2 times 3 times 3 times 5, and that is 180. So it's 180. If we were asked for the lowest common multiple, it'd be all of these numbers multiplied together. 2 times 2 times 2 times 3 times 3 times 3 times 5. So the lowest common multiple is all of them times together. The highest common factor, just the ones in common times together. Question 2. Verity buys 12 bottles of apple juice for a total cost of £15. Verity sells all 12 bottles at £1.75 for each bottle. Work out Verity's percentage profit. So if we have percentage profit or percentage change, we're looking for the change divided by the original, and then to make it a percentage times 100. So how much is it changed by? What's the profit? 12 times £1.75. She sells them for £21. She bought them for £15. So that's a £6 profit. So the change is £6. The original cost was £15. And to make it a percentage, times by 100. So 6/15 times 100 is 40. So it's 40%. The percentage profit is 40%. Question 3. The table shows the populations of 5 countries, and we've got the populations given to us in standard form. Part A, work out the difference between the population of India and the population of Turkey. Give your answer in standard form. So the difference means take away. So population of India, 1.4 times 10 to the power of 9. Take away the population of Turkey, 8.4 times 10 to the power of 7. We can just use the calculator for this, and we can use the standard form button. So 1.4 times 10 to the power of 9. Take away 8.4 times 10 to the power of 7. And we get our answer. So 1316, and then 6 zeros. 1316, and then 6 zeros. So that's 1,316,000,000. We need to give our answer in standard form. We can't give our answer as an ordinary number. So to make it standard form, we write the number between 1 and 10 times 10 to a power. So 1.316 times 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 times. The power of 9 is billions. So that is our answer. Part B, given that the population of Iceland is 1 over k times the population of Denmark, work out the value of k. So the population of Iceland, 3.4 times 10 to the power of 5 is equal to 1 over k times the population of Denmark, 5.8 times 10 to the power of 6. So to find K, so K times the population of Iceland is equal to the population of Denmark. To find K, it's the population of Denmark divided by the population of Iceland. And again, we can just use the standard form button. So 5.8 times 10 to the power of 6 divided by 3.4 times 10 to the power of 5. We want the nearest whole number. So to the nearest whole number, we have 17. So K is 17th. The population of Iceland is a 17th of the population of Denmark. Question 4. The diagram shows the front of a wooden door with a semicircular glass window. And Julie wants to apply 2 coats of wood varnish to the front of the door, so the shaded area, and 250 milliliters of wood varnish covers 4 meters squared. How many milliliters of wood varnish does Julie need? So it's the shaded area, and then times 2 for 2 coats, and then we'll use this information. So 250 milliliters for 4 meters squared. 250 divided by 4 is 62.5. So it's 62.5 milliliters per meter squared. So we'll work out the area in meters squared, times it by 2, and then times it by 62.5. So the area of the shaded region is the rectangle, take away the semicircle. So area of rectangle, 2 times 0.75, which is 1.5 meters squared. Area of semicircle, so it's pi r squared divided by 2. 0.5 is the diameter, so the radius is half of that. So it's pi times the radius squared halved, because it's a semicircle, it's not the full circle. Pi times the radius squared divided by 2 is 0.098. So now we can work out the shaded area. 1.5 take away 0.098. 1.5 take away the answer. 1.40. So that's the shaded area. We need 2 coats. So 2 lots of that is 2.80 meters squared. So we need to cover 2.80 meters squared. It's 62.5 milliliters per meter squared. So 2.8 times 62.5 is 175 milliliters. To the nearest milliliter, 175. So 175 milliliters of wood varnish are needed. Question 5. So we have A, B, C, D and F, G, H, I are parallel straight lines. E, B, G, J and E, C, H are straight lines. B, E is C, E. B and C are equal. They're shown by these lines. That means the 2 lengths are equal. And the parallel lines are shown by these arrows. We need to work out JGH, which is this angle here, and we have to give a reason for each stage of our working. So the angles at the base of an isosceles triangle, these two, it's an isosceles triangle because it's got two equal lengths. That means it's got two equal angles. The angles at the base of an isosceles triangle are equal. So 180 take away 48 divided by 2 is 66. So we can say EBC is 66 degrees because the angles at the base of an isosceles triangle are equal. We can show our complete working by doing the calculation. Then we have the angles on a straight line. So angles on a straight line add up to 180 degrees. So GBC is 114 degrees because angles on a straight line add to 180 degrees. And finally, we have corresponding angles are equal. So when we have a straight line going through parallel lines, it makes exactly the same angles with both lines. So the straight lines going through the parallel lines make the same angles twice. So this angle and this angle are exactly the same. They're corresponding angles. This angle and this angle are exactly the same. They're corresponding angles. And this 66 degrees is also 66 degrees here because those two are corresponding angles. So our angle is 114 degrees because corresponding angles are equal. Question 6. Adam drove 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Adam's average speed from Liverpool to Manchester was 80 kilometers per hour. Adam took 85 minutes to drive from Manchester to Sheffield. Work out Adam's average speed for his total drive from Liverpool to Sheffield. So his average speed for the whole journey is going to be his total distance divided by the total time. So from Liverpool to Manchester, we know the distance was 56 kilometers and the speed was 80 kilometers per hour. So we can work out the time by doing the distance divided by the speed. So time is going to be distance divided by speed, which is 56 divided by 80. 56 over 80 is 7/10. That's 7/10 of an hour, 0.7 hours. So do we know all the information now? So the total distance we can add together. The total time we can add together, but we've got Manchester to Sheffield in minutes. So to change from minutes to hours, we can divide by 60. 85 over 60 is 1.416 recurring. If we add on the 0.7, we've got 2.116 recurring hours. So the speed is the total distance, 56 plus 61, divided by the total time, 2.116 recurring. So if we just type that into the calculator, we'll use the answer button for this. So 56 plus 61 over the answer is 55.3 kilometers per hour. Bev drove from Reading to Bristol. Bev's average speed from Reading to Swindon was 80 kilometers per hour. Her average speed from Swindon to Bristol was 60 kilometers per hour. Bev says that the average speed from Reading to Bristol can be found by working out the mean of 80 kilometers per hour and 60 kilometers per hour. If Bev is correct, what does this tell you about the two parts of Bev's journey? So the only way that you can find the average speed by just finding the mean of the two speeds is if the time must be the same. So the time for each part of the journey must be equal. So if you drive at 80 kilometers per hour for 1 hour and 60 kilometers per hour for 1 hour, you've gone 140 kilometers in 2 hours, which is 70 kilometers per hour. So if the two times are the same, you can just average the two speeds, but in any other case, that won't work. Question 7. A company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. 2 of the machines are not working and cannot be used to make the boxes. Work out the total number of days taken to make all the boxes. So 6 machines for 9 days. 6 times 9 is 54. So it takes 54 days in total, and that will be how long it takes one machine. So if you had 2 machines, you can share those 54 days between 2 machines. If you had 3 machines, split those 54 days of work between 3 machines, and so on. So we've got 6 machines, 2 not working. That means we've got 4 machines. So divide the work that needs to be done between the 4 machines, and it will take 13.5 days. So we could say 13.5 days. The total number of days, we could say 14 days. I'll put 13.5. Janet bought a new car 3 years ago. At the end of the first year, the value decreased by 17.5%. The value decreased by 10% each year for the next 2 years. And then at the end of 3 years, the car was worth £16,038. Work out the value of the car when Janet bought it 3 years ago. So we had an original amount, and then we have to take off 17.5%. So to take off 17.5% in one calculation, 100 minus 17.5 is 82.5, and as a decimal, that's 0.825. So to take off 17.5%, we can multiply by 0.825. It then goes down by 10%. So that's 100% take away 10% is 90%. So to take away 10%, we can times by 0.9. And we're doing that for 2 years. So do that twice. And then it should be equal to £16,038. So we had a number, we took off 17.5%, then we took off 10% twice, and we get £16,038. So to find our original number, we just get x by itself. At the moment it's multiplied by this. So we do the opposite of timesing, which is dividing. So divide by this number. So that gives us £16,038 divided by 0.825 times 0.9 squared, and that's £24,000. So if you start with 24,000, take off 17.5%, and then take off 10%, and take off 10% again, you get £16,038. Question 9, simplify fully. So we've got 16x to the power of 4 divided by 9y to the power of 10, and that's all to the power of minus a half. So the power of a half means square root, and a negative in the power means flip. It's the reciprocal. So flip it over. So we need to square root it and flip it. So if I flip it first, the bottom becomes the top and the top becomes the bottom. And now I need to square root it. So square root everything. So the square root of 9 is 3. The square root of y to the power of 10 is y to the power of 5. Y to the power of 5 times y to the power of 5 is equal to y to the power of 10. So y to the power of 5 squared is y to the power of 10. So the square root of y to the power of 10 is y to the power of 5. And on the bottom, square root 16 is 4. And square root x to the power of 4 is x squared. So that is simplified fully. We can't simplify it anymore. So 3y to the power of 5 over 4x squared. Question 10, expand and simplify. So we're expanding triple brackets. We're going to expand the first two and leave the last one as it is to start with, and then we'll expand again. So 2 times 2x is 4x. 2 3s are 6. Negative x times 2x is negative 2x squared. Negative x times 3, negative 3x. And I'm going to leave the last bracket as it is. I'm going to simplify the first bracket. The only like terms I've got are 4x and negative 3x. So 4x, take away 3x, is just 1x. So I've got x plus 6 minus 2x squared times x plus 4. Now I'm going to expand again. I'm going to multiply each of the 3 terms in the first bracket by both of the terms in the second bracket, and that's going to give me 6 terms. So x times x, x squared, x times 4, 4x, 6 times x is 6x, 6 4s are 24, minus 2x squared times x, a negative times a positive is negative, 2x squared times x is 2x cubed. Again, a negative times a positive is negative. 2x squared times 4 is 8x squared. So collecting the like terms, x cubed, I've got minus 2x cubed. For x squared, I've got 1 take away 8, which is minus 7 x squareds. For x's, 4 plus 6 is 10 x's, and I've just got 24. So that's my answer, minus 2x cubed minus 7x squared plus 10x plus 24. Question 11. The box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. we need to work out the interquartile range for the amount of money spent. So we've got a box plot. It's the lowest, the lower quartile, the median, the upper quartile, and the highest amount. So the interquartile range be the upper quartile, this one here, take away the lower quartile, this line here. So it is, so each small box is 20. So it's 330 for the upper quartile, take away 150 for the lower quartile. So the interquartile range is £180. The table below shows information about the distribution of the amount spent by some female students on their holidays. And we need to draw the box plot. So it's 60, 180. So 60 for the lowest. Then 180. 300 for the median, 350 for the upper quartile, and 650 for the highest amount. So we do a box around the lower quartile, median, upper quartile, and lines out to the highest and the lowest amount. So there is our box plot, and we can label it as well, female students. Chris says the box plots show that female students spent more money than male students. Is Chris correct? So we could argue this both ways. We could say that the female students spent more. We could say yes because the median's more. Or you could also say no, the highest amount was more for the males, so they spent more. So you could argue it both ways, but we can say the median, the average amount spent by females was greater. So I'm going to say yes, the median amount spent by female students was greater. Question 12. Using algebra, show that the recurring decimal 0.18 and then 03 recurring is equal to 119 over 660. So we're going to let 0.18 and then 03 recurring be called x. And what we're looking for is two things that end in 03 recurring. Two numbers ending in 03, 03, 03, 03, and so on. So if I multiply this by 100, I'll get 18.03 recurring as 100 lots of x. That's one thing that ends in the 03. If I times this by 100 again, 1803.03 recurring is 10,000 lots of x. Then I've got two things ending in 03 recurring, and I can take them away. So 10,000 take away 100 is 9,900. 1,803 point something take away 18 point something is 1,785. So to change this to a fraction, I divide both sides by 9,900. So x is 1,785 divided by 9,900. And if we simplify that fraction, we should get 119 over 660. Question 13. Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 210 fish from the lake. She puts a tag on each of these fish and puts them back into the lake. On Saturday, Saffron catches 240 fish from the same lake. She finds 35 of the 240 are tagged. Work out an estimate for the total number of fish in the lake. So we've got a capture, recapture question. And it's like an equivalent fraction question. So 210 fish out of the total have got a tag. And that should be equal to the second fraction, 35 out of 240. So the fraction of fish with a tag on Friday should be the same, equal to the fraction of fish with a tag on Saturday. So what's x got to be for these two to be equivalent? We can say, what you times 35 by to get to 210? And that is 6. So if I times the top by 6, I also times the bottom by 6. So 240 times by 6 is 1,440. Question 14. PQ, R and S are 4 points on a circle, center X. PXR and SXQ are straight lines. Prove that triangle PQX and triangle SRX are congruent. Prove that they're the same. So to be congruent triangles, we need to prove either they've got three sides the same, they've got side, angle in between them and side, or angle, side in between, an angle, or a right angle with a hypotenuse on one other side. So we can have SAS, SSS, ASA, or RHS. We need to get to one of those arguments. We need to show that three things are the same, and then we can prove they're congruent. So we can say that P to X and X to R and S to X and X to Q are all the same because they're all a radius. So PX equals XR and SX equals XQ because they are all the radius of the circle. And then we can say we've got opposite angles here. So PX angle PXQ equals SXR because opposite angles are equal, or vertically opposite angles are equal. So we've shown we've got a side, an angle, and a side. Side, angle, side. So they are congruent triangles. They must be equal. So if they've got side, angle, side, therefore they must be congruent. What we could also say, that finishes the question, but what we could also say is these two angles are equal because they're angles in the same segment. Angles in the same segment are equal. So we can also say we've got angle, side, angle. But we don't need to carry on, make any more arguments because we have proved we've got side, angle, side. Therefore, they are congruent. Question 15. Here is a speed time graph for a train. Work out an estimate for the distance the train travelled in the first 20 seconds use 4 strips of equal width. So when we're finding the distance from a speed time graph, that's the area under the curve. So the area under the curve is the distance. And if we're finding the acceleration, which we're not in this question, but if we were asked to find the acceleration, that would be the gradient at a point. So if we wanted the acceleration at 10 seconds, we'll draw a tangent at 10 seconds and work out the gradient of it. But we want to find the distance, so it's area under the first 20 seconds using 4 strips. So we're going to have this triangle. Then 3 trapeziums. So 1, 2, 3. So we have area of a triangle, which is half the base times the height. So that's 1, 2. Half the base times the height. We've got a trapezium, so half the sum of the parallel sides. So half of 2 plus 5 times the distance between them, which is 5. For the third one, we've got half of 5 plus 10 times the distance between them, which is 5 again. And the fourth one, half of 10 plus 18, half of 10 plus 18 times the distance between them, which is 5 again. So we have half of 2 times 5 for the triangle, which is 5. Half of 2 plus 5 times 5, 17.5. So 17.5. Half of 5 plus 10 times 5, which is 37.5. And half of 10 plus 18 times 5, which is 70. So we've got an area of 5, an area of 17.5, a 37.5, and a 70. So the total distance is, adding them all together, and that is 130 meters. Is your answer to part A an underestimate or an overestimate of the actual distance traveled? So the actual distance traveled is the area under the curve. So we have these extra bits. We've included these extra areas here in between our trapeziums and our triangle and the curve. So we have overestimated. Our area is bigger than the area under the curve. So it's an overestimate. The area under the trapeziums is greater than the area under the curve. So we've got extra areas here. Question 16. Using algebra, prove that given any 3 consecutive even numbers, so 3 consecutive even numbers, if we call the first even number 2n, the one after it, the one after 2n is 2 more, so 2n plus 2, and the one after that is 2 more again, 2n plus 4. The difference, so takeaway, between the square of the largest and smallest is always 8 times the middle number. So the difference between the square of the largest and smallest. So that's 2n plus 4 squared, difference means take away, minus 2n squared. And that should be equal to 8 times this. So for squared, 2n plus 4 squared means 2n plus 4 times 2n plus 4. And 2n all squared is 2n times 2n, which is 4n squared. So expanding these brackets, 2n times 2n, 4n squared, 2n times 4 is 8n, 4 times 2n is 8n, 4 4s are 16. So collecting the like terms, we've got 4n squared take away 4n squared, which is nothing. And we've got 8n plus 8n, which is 16n. And we've got 16. So we've got 16n plus 16. And is that 8 times the middle number? The middle number is 2n plus 2. So 8 times 2n plus 2. If we expand the brackets, we get 16n plus 16. Question 17. The straight line L passes through the points 4, -2 and 6, 5. The straight line M is perpendicular to L and intersects the y-axis at 0, 3. Find the coordinates where M intersects the x-axis. So we need to find the gradient of L and then find the perpendicular gradient for M. So the gradient is the change in y divided by the change in x. So the change in y divided by the change in x. We can call that y2 minus y1. So 5 minus minus 2 over x2 minus x1, 6 minus 4. 5 minus minus 2 is 7. 6 minus 4 is 2. So the gradient of L is 7 over 2. So the gradient of M, the perpendicular gradient, it's a negative reciprocal, flip a minus. So the perpendicular gradient is negative 2/7. And it intersects the y-axis at 0, 3. So 0, 3, 3 is the y-intercept. So we can say the equation of M, it has the equation y equals minus 2/7 x minus 2/7 x plus 3. Y equals mx plus c, where m is the gradient and c is the y-intercept. So the equation is y equals minus 2/7 x plus 3. We need to know where it intersects the x-axis. So this is its equation. We've got its equation now. Where does it intersect the x-axis? It crosses the x-axis when y equals 0. So if you've got a straight line, this is a straight line like this. So it crosses the x-axis when its y-coordinate is equal to 0. So if we make the y-coordinate 0, we can find where it crosses the x-axis. So 0 is minus 2/7 times x plus 3. So we're solving an equation now. So take away 3 from both sides. Negative 3 is minus 2/7 x times both sides by 7. Negative 21 is minus 2x. So we've got x is negative 21 divided by negative 2. A negative divided by a negative is positive. Negative 21 divided by negative 2 is 21 over 2, or 10.5. So it crosses the x-axis. Its x-coordinate is 10.5. and its y coordinate is 0. Question 18. Show that x over x plus 3 minus 2x minus 1 over x minus 3 plus 1 can be written in the form ax plus b over x squared minus 9, where a and b are integers. So here we're adding the fractions together. And to add fractions together, we need to make the denominators the same. So to make the denominators the same, we're just going to times them together. And whatever we times the top by, we'll times the bottom by the same thing. So for our first fraction, we're going to times the top and the bottom by x minus 3. And that will make the denominator x plus 3 times x minus 3. For our second fraction, times top and bottom by x plus 3. So then they have the same denominator. And for the 1, you could think of it as 1 over 1 to start with. We're going to times the top and the bottom by x plus 3 times x minus 3. So it's x plus 3 times x minus 3 over x plus 3 times x minus 3. So now all the denominators are the same. We can make it into one fraction. And we're going to have to expand lots of brackets here. So we're going to expand all of these. We're going to have to be particularly careful with this minus sign because we want to take away all of this. So when we expand it, we'll keep a bracket around it. And then when we take it away, we can take away each term, not just the first term. We're taking away every term. So x times x is x squared. X times negative 3, negative 3x. And then I'm going to put this extra bracket in. 2x times x, 2x squared. 2x times 3, 6x. Negative 1 times x minus x. Negative 1 times 3 is negative 3. Plus x times x is x squared. X times negative 3 is minus 3x. 3 times x is 3x. And 3 negative 3's and negative 9. This one here is the difference of two squares. X plus 3 times x minus 3 expands to give x squared minus 9. It's the difference of two squares. And that's why this x squared minus 9 comes from in our denominator. So it's all over x squared minus 9. So we have x squared minus 3x minus, I'm going to keep this big bracket here for now, 2x squared. We've got 6x take away another x, which is 5x minus 3 plus x squared minus 9. And that is all over x squared minus 9. Now I'm going to get rid of this bracket, so I'm taking away each term. That's the same as multiplying each term inside the bracket by a negative 1. So it's going to change the sign of every term we have here. So x squared minus 3x minus 2x squared minus 5x plus 3 plus x squared minus 9. All over x squared minus 9. So just collecting the like terms now, we've got x squared minus 2x squared plus another x squared. That's no x squareds, they cancel out. We have negative 3x take away another 5x, which goes to minus 8x. And we have 3 take away 9, which is minus 6. And that is our answer. Question 19. Express 9 plus 8x minus 2x squared in the form a plus b times x plus c squared, where a, b, and c are integers. So we're completing the square, but we've been given quite a difficult question because we've got a minus 2x squared. So we're going to have to get rid of that minus 2x squared before we can complete the square. We just want a normal x squared. So to get rid of it, we're going to factorize. So we're going to take negative 2. We're going to take the thing in front of the x squared out of the bracket. I'm going to leave the 9. I'm going to take minus 2 outside of these two terms. So minus 2 times something will give me 8x. So a negative times a negative will give me a positive. So minus 2 times negative 4x will give me 8x. And minus 2 times x squared will give me minus 2x squared. And I'll write those the other way around. I'll write x squared minus 4x. So now I'm going to complete the square on this bit. X squared minus 4x. So I've got 9 minus 2. And then I'll do a big bracket. And I'm going to complete the square on this bit. So I've got x. I'm going to half the x term. Half negative 4, which is negative 2. So I want x minus 2 squared. And then take away this number squared, which is 4. So x squared minus 4x is the same as x minus 2 squared, take away 4. Now I'm going to expand this bracket back. So we've got one term here and another term here. So we're going to multiply negative 2 by both of these two terms. So we've got 9 minus 2 times x minus 2 squared. And then negative 2 times negative 4 is plus 8. And collecting the like terms, we've got 9 and 8. That makes 17. So we've got 17 minus 2 times x minus 2 squared. And that is our answer. So you might see an easier completing the square question. You might just have, let me write that answer in first, 17 minus 2 times x minus 2 squared. You might have a much easier question where you have something like x squared plus 10x minus 3, in which case you don't have to do any of these steps first. We just half the middle number. So at the moment we've got 10, half of it is 5. So it's x plus 5 squared. Then we take away the 5 squared, which is 25. And we've still got the minus 3 on the end. So it's x plus 5 squared minus 28. Back to this question. C is the curve with equation y equals 9 plus 8x minus 2x squared. That's this curve. That's this line curve. The point A is the maximum point on C. Use your answer to part A to write down the coordinates of A. So we've got y equals 17 minus 2 times x minus 2 squared. The maximum point is going to be where this bracket is equal to 0. So what does x have to be for that bracket to be 0? That is 2. So x is 2. And then what is y at that point? So we've got 17 minus 2 lots of 0, which is 0. So we're just left with 17. So it's 217. Question 20. Triangle A is transformed by the combined transformation of a reflection in the x-axis. Let's do that first. So this point, it's 1 away, so 1 away on the other side. 1 away, and 1, 2, 3, 4. 1, 2, 3, 4. So reflection in the x-axis, followed by reflection in the line x equals negative 2. So we have one away on the other side. 1, 2, 1, 2, 1.5, 1.5. Followed by a translation with vector -4, 2. So the first one is x change, then the bottom one's the y change. So left 4, up 2. So then we take our triangle to the left 4, 1, 2, 3, 4, up 2. So it becomes that triangle. 1 point on triangle A is invariant under the combined transformation. Find the coordinates of this point. So the invariant point hasn't changed. It's still in the same place it was to start with. So that is this point here. So it was reflected over to become this point, then reflected again to become this point, and then it moved 1, 2, 3, 4 to the left, and 2 up, and it went back to where it started. So that's -4, 1. So that point, -4, 1, is invariant. It's still in the same place it started. Question 21. Prove algebraically that the straight line with equation 2x plus y plus 5 equals 0 is a tangent to the circle with equation x squared plus y squared equals 5. I'm going to do a quick sketch of this. You don't have to. Actually, I'm going to make this in the form y equals mx plus c first. So if I take away 2x from both sides and take away 5 from both sides, it's y equals minus 2x minus 5. So a quick sketch. So we've got a circle, which is x squared plus y squared equals the radius squared. So we know the radius of the circle is, well, square root 5, which is just over 2. So we've got a circle, and this line's got equation minus 2x minus 5. So it's got a negative gradient, so it's going down, and a y-intercept of -5. So it's something like this. So it's a tangent, which means it just touches the circle. We can prove that it's a tangent by trying to find the points of intersection. And the points of intersection we find by using simultaneous equations. So if we try and solve these two as simultaneous equations, and there's only one point where the line touches the circle, then we're only going to get one answer to our simultaneous equations. If the line went through the circle, it would cross it at 2 points. We'll get 2 answers. So if we try and solve these simultaneous equations by substituting this line, this y equals minus 2x minus 5 into our circle and solve, we should only get one solution. So x squared plus y squared minus 2x minus 5 squared equals 5. So let's expand and simplify this. So minus 2x minus 5 times minus 2x minus 5 equals 5. So x squared plus 4x squared plus 10x plus 10x plus 25, a negative times a negative is a positive every time, equals 5. So we've got 5x squareds, 20x's plus 25 equals 5. And then take away 5 from both sides to make it equal to 0. Whenever we want to solve a quadratic, we make it equal to 0 first. We can divide through by 5. X squared plus 4x plus 4 equals 0. So we don't have to use the quadratic formula here. This factorizes. what multiplies to make 4 and adds to make 4? It's 2 times 2. So there's only one solution. X is negative 2. So one solution. And because there's only one solution, I'll find the y coordinate as well. So y is, we weren't asked to, minus 2x minus 5, minus 2 times minus 2 minus 5. Negative times a negative is positive. So minus 2 times minus 2 is 4. 4 take away 5 is minus 1. So it's a tangent. The line is a tangent. It only touches the circle. At negative 2, negative 1. So it's only touching the circle at this one point, negative 2, negative 1. Therefore, it must be a tangent. Question 22. The diagram shows two circles such that the region R, shown shaded in the diagram, is a region common to both circles. One of the circles has center O, radius 5. The other circle, center P, radius 4. AOB is 50 degrees. And we need to calculate the area of the shaded region. So this is a radius. So this is a radius as well, 5 centimeters. This is a radius. And this is a radius. They're both 4 centimeters. So what we can do, we're going to find the area of these two segments. So we've got one segment for our small circle, one segment for our big circle, and we can find the area of a segment by doing the area of a sector minus the area of the triangle. But before we can do that for the big circle, because we know the angle. We need to find the angle for the small circle first. So to do that, we're going to have to use the cosine rule to find this length AB, and then the cosine rule again to find the angle. So we're going to use the cosine rule twice, once to find the length, and then once we've found that length, we'll use it again to find the angle, and then we can work out the area of the sectors and the areas of the triangles and take them away. So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a. So to find this length, we can say a squared equals 5 squared plus 5 squared minus 2 times 5 times 5 cos 50. 5 squared plus 5 squared minus 2 times 5 cos 50. So a squared is 17.86. So the length is the square root of that, which is 4.23. 4.23 centimeters. So that's the red line here. Then we can use the cosine rule again. When we're finding an angle using the cosine rule, it's better to use the rearranged version. So that's the original version. We can rearrange it by adding 2bc cos a to both sides. So a squared plus 2bc cos a equals b squared plus c squared. Then take away a squared. So 2bc cos a is b squared plus c squared, take away a squared, and then divide by 2bc. So cos a is b squared plus c squared minus a squared over 2bc. So to find this angle, we are going to say that cos a is equal to 4 squared plus 4 squared, take away 4.23 squared over 2 times 4 times 4. because this one is big A, the one opposite it is little a, and these two are B and C. So we can just type that into the calculator. 4 squared plus 4 squared minus the answer squared over 2 times 4 times 4 is 0.442. That's cos A is 0.442. To find the angle, we do shift cos. So the angle is 63.8 degrees. And I'll save that in the calculator as A. So now we can work out the area of the sectors and take away the area of the triangles. So the area of a sector is the area of the whole circle times a fraction of the circle we've got. So for the big circle, sector, let's just write sector area, it's 50 degrees out of 360 times the area of the whole circle, which is pi times the radius squared. So 50 over 360 times pi times the radius squared. So 10.9. So the sector area is 10.9. And we want to take away the area of the triangle. So this triangle, OAB, we can find the area of a triangle using half AB sine C. So half times A times B sine C. So it's 10.9. So the big sector segment is 10.9 minus this, half AB sine C. So minus half times A times B sine C. So we've got 1.33. So 1.33 centimeters squared. So that's the big sector segment, the big circle segment even, which is that part there. That's 1.33. I'm going to store that in the calculator as well. I'll call that one B. I just make a note to say I've stored that as B, so I don't forget. And I've stored this one as A. Then for the little circle, the segment, I'll try and do it in one calculation. So it's the area of the sector, 63.8 out of 360 times pi times the radius squared minus the area of the triangle, half AB sine C. So we have A over 360 times pi times the radius squared minus half AB sine C, which is stored as A. The angle is stored as A. And that's 1.73. And again, that's in centimeters squared. So the total area is our 1.33 plus our 1.73. That's answer plus the B we stored in the calculator, 3.06. So 3.06 centimeters squared.